To truly find your place in the universe, you must first become hopelessly, terrifyingly lost. You're floating in an impossible abyss, a silent theatre of crushing blackness, punctuated by the hard, indifferent light of a billion distant stars. There is no up or down, no east or west. The familiar anchors of your terrestrial existence have been cut away, leaving you adrift in the velvet void. Your only tether, your only point of reference in all of creation, hangs before you now. It is a swirl of brilliant white cloud, a splash of impossible blue ocean, and the muted ochre continents of home. Below you, suspended in the stillness, is not a country, not a map, but a living, breathing planet, Earth. For the first few million years of our history, this perspective was the exclusive domain of gods and mystics. We were a species bound to the surface, our gaze fixed either down at the soil or up at the celestial ceiling, but never back upon ourselves. Our world was a flat, infinite expanse, the unmoving centre of everything. Our minds, our philosophies, and our identities were forged in this terrestrial crucible, shaped by the gravity that held us and the horizon that limited our view. We were creatures of the landscape, intimately familiar with our immediate surroundings but profoundly ignorant of the whole. That profound, species-wide ignorance was shattered in a single moment on a cold December morning in 1968. 3 men, the first humans to ever leave the gravitational embrace of Earth and orbit another world, were rounding the far side of the moon. They were explorers, test pilots, men of science and steel, focused intently on the barren, pockmarked lunar surface below. Their mission was a technical rehearsal, a scouting run for a future landing. But as their Apollo 8 capsule pivoted, a sight no human eye had ever witnessed before rose above the sterile grey horizon. It was a delicate, half-illuminated crescent of impossible colour and life. It was Earthrise. In that moment of unplanned, unscripted awe, astronaut Bill Anders grabbed a camera. The photograph he took would become an icon, a visual anchor for a new kind of consciousness. For the first time, humanity saw itself not from within, but from without. We saw not a collection of warring tribes on a limitless plain, but a unified, fragile, and utterly isolated whole. That image cascaded across the globe, a silent testament to our shared destiny. It became a symbol for the burgeoning environmental movement and a quiet rebuke to the bitter divisions of the Cold War. But for the few hundred souls who have followed in the footsteps of those Apollo pioneers, who have personally witnessed that vision with their own eyes, the experience is not merely symbolic, it is visceral, it is transformative. It is a phenomenon so profound, so consistently reported, that it has earned its own name, the overview effect. It is a fundamental shift in awareness, a cognitive recalibration that occurs when a human being sees their world from the outside. The reports, trickling back from orbit for over half a century, form a chorus of startling consistency. They speak of an experience that transcends language, a feeling that borders on the spiritual. For some, the revelation is a sudden, intellectual thunderclap. Edgar Mitchell, the 6th man to walk on the moon, described an epiphany on his journey home. Staring at the Earth spinning in the void, he was overcome with the certainty that every molecule in his body, every atom in the spaceship, and every particle in the universe itself was part of a single, conscious, interconnected system. It was not a belief, but a direct knowing, an intuitive understanding of physics and cosmology that washed over him with the force of a religious experience. He would spend the rest of his life trying to understand and articulate that single, powerful moment of cosmic unity, a feeling of belonging to the universe on the most fundamental level imaginable. His experience wasn't unique, it was simply one of the most eloquent expressions of a common theme. For others, the shift unfolds more gently, a slow, blooming awareness of the planet's sheer fragility. Astronauts speak of the atmosphere, that gossamer-thin membrane that shields all life from the vacuum of space. From the ground, it seems like an infinite, boundless sky. But from orbit, they see it for what it truly is, a delicate, impossibly thin blue line, a film of gas as tenuous as the skin on an apple. Seeing this fragility firsthand, day after day, instills a powerful, almost parental sense of protectiveness. Chris Hadfield, the Canadian commander of the International Space Station, described how you can see the planet breathing. You can watch massive weather systems form and dissipate, see colossal dust storms sweep across entire continents, and witness the spread of wildfires as orange scars on the darkened globe. You cease to be a resident of a town or a citizen of a nation. You become a crewmate on Spaceship Earth, acutely aware that the ship's life support systems are finite and delicate. This dissolution of borders is perhaps the most universally reported aspect of the effect. From 250 miles up, the intricate arbitrary lines we have drawn on maps for millennia simply vanish. They are invisible. Political boundaries, ethnic divides, and national rivalries become what they truly are: human constructs, invisible fictions overlaid upon a single, continuous, and integrated ecosystem. You don't see the United States or China, you see a land mass. You don't see the Middle East, you see a cradle of civilization where deserts meet the sea. Russian cosmonaut Yuri Gagarin, the very first human in space, was struck by this immediately, marvelling at how beautiful and borderless our planet appeared. That sentiment has been echoed by every single space traveller since, regardless of their nationality or ideology. The perspective from orbit offers a truth that is self-evident. We are one species, sharing one home. This realization is not an intellectual exercise, it is an emotional and undeniable reality. The experience is so powerful it often drives these pragmatic, scientifically minded individuals to become artists and poets. Astronaut Nicole Stott spent her time on the space station painting what she saw, trying to capture the vibrant, impossible colours of an orbital sunset or the turquoise glow of the Caribbean Sea. She felt an overwhelming need to share the view, to communicate the feeling of seeing Earth not as a static object, but as a living work of art. Her story is one among many. Astronauts return to Earth as advocates, as environmentalists, as humanitarians. They carry with them a permanent change in their worldview, a sense of responsibility for the planet that never fades. They have seen the whole picture, and it has changed them forever. This consistent, cross-cultural and deeply personal transformation was documented and given its name by the space philosopher Frank White. He wasn't an astronaut, but a keen observer who noticed this pattern emerging from the stories of those who had ventured beyond the sky. White interviewed dozens of spacefarers, meticulously cataloguing their experiences. He realized he was not just hearing anecdotes about a beautiful view. He was documenting a new psychological state, a cognitive shift unique to the human experience of spaceflight. He defined the overview effect as the moment when astronauts develop a new or more nuanced understanding of their relationship with the planet and humanity as a whole. It's a perception of Earth as a tiny, fragile ball of life, hanging in the void, shielded and nourished by a paper-thin atmosphere. He described it as an epistemological rupture, a break in our normal way of knowing. On Earth, we're inside the system, unable to perceive its totality. In space, for the first time, we're outside the system looking in. This shift from inhabitant to observer changes the very framework of our thoughts. The problems that seem so monumental and intractable on the ground, political squabbles, economic crises, cultural conflicts, are suddenly seen in their proper cosmic perspective, as the small, localized struggles of a single, interdependent family. The implications are staggering. For millennia, our great thinkers have tried to cultivate this kind of global consciousness through philosophy, meditation, and religion. We have been urged to see ourselves as part of a larger whole, to transcend our tribal instincts and embrace a sense of universal kinship. Yet what centuries of thought have struggled to achieve, a 15-minute orbital pass seems to accomplish with breathtaking efficiency. It suggests that this perspective is not something we need to learn, but something we need to see. It is a latent potential within the human mind, waiting to be unlocked by the right stimulus. The view from space, it seems, is the key. But for all its poetry, for all its power to inspire a new kind of humanism, a question has lingered in the quiet corridors of science for decades. A question that is both profound and unsettling. Is this beautiful poetic transformation merely an emotional product of a sublime experience? Is it just the logical, psychological reaction to seeing something magnificent and unique, akin to the awe one might feel standing at the edge of the Grand Canyon or witnessing a total solar eclipse, just amplified on a planetary scale? Or is something else happening? Something deeper? Is the very architecture of the human brain, the 3-pound universe of tangled neurons and electrical whispers inside our skulls, being physically and fundamentally altered by the journey beyond Earth? The human brain is not a static piece of hardware. It is a dynamic, living network, constantly rewiring itself based on the input it receives from the environment. This property, known as neuroplasticity, is the basis for all learning and memory. Our brains are sculpted by our experiences, by the sights we see, the sounds we hear, and the physical forces we encounter. From the moment we are born, our brains are calibrated to a very specific set of environmental parameters: a constant gravitational pull of 1G, a 24-hour cycle of light and dark, a particular range of atmospheric pressure, and a sensory landscape defined by horizons and terrestrial physics. Our neural pathways, our sense of balance, our spatial awareness, and even our cognitive maps of the world are all built upon this stable, predictable foundation. When you go to space, you leave all of that behind. You enter an environment for which our biology has no evolutionary precedent. Gravity, the most constant and pervasive force in our lives, simply vanishes. The concepts of up and down, which are so fundamental to our perception of reality, become meaningless. Your inner ear, the delicate gravitational gyroscope that has guided your every movement, is suddenly thrown into chaos, struggling to find a signal that is no longer there. Your sensory inputs are both deprived and overwhelmed. You're confined to a small, sterile metallic box, yet you are staring out at the infinite. You're subjected to a constant flux of cosmic radiation, imperceptible particles that pass through the hull of your ship and the very cells of your brain. The familiar rhythms of day and night are replaced by a dizzying cycle of 16 sunrises and sunsets every 24 hours. Is it possible that this radical and sustained assault on our biology, this complete upending of the environmental constants that shaped our neural architecture, is doing more than just inspiring awe? Could it be forcing the brain to adapt in ways we're only just beginning to understand? Perhaps the overview effect is not simply a new thought, but the cognitive echo of a physical rewiring. Perhaps the dissolution of borders seen from the window is mirrored by a dissolution of old neural pathways within the mind. Maybe the feeling of interconnectedness is the conscious experience of the brain forging new, more holistic connections in a desperate attempt to make sense of an environment that defies all terrestrial logic. This is the central mystery we seek to unravel. The question is no longer just what the astronauts feel, but why they feel it. We're moving beyond the realm of poetry and into the frontier of neuroscience. To find the answer, we must embark on a new kind of exploration. This journey will not take us to distant stars, but deep into the inner space of the human mind. We will venture into the silent, pressurized world of isolation chambers on Earth, where scientists simulate the confinement of space travel to study its psychological toll. We will connect astronauts to sophisticated brain scanning equipment, measuring the electrical tides and blood flow in their brains before, during, and after their missions, searching for the physical signature of this cognitive shift. We will map the strange new landscape of the brain as it learns to navigate a world without gravity, observing how it relocates resources once dedicated to balance and orientation. We will listen to the electrical whispers of neurons as they process the sublime, trying to understand the neurological basis of awe itself. We will investigate the subtle, long-term changes that may persist for years after an astronaut returns, asking if leaving Earth leaves a permanent, physiological imprint on the human connectome. The story of the overview effect is the story of two frontiers meeting: the exploration of outer space and the exploration of human consciousness. It is a story that suggests that as we push outward into the cosmos, we are also, inevitably, pushing inward, discovering what it truly means to be human. The greatest discoveries of our journey to the stars may not be on other worlds, but within ourselves. What happens when a mind, evolved over millions of years to navigate a world defined by horizons and gravity, is suddenly lifted from its cradle. For all of our existence, we have been creatures of the surface, our perspective tethered to the ground, our thoughts shaped by the immediate landscape. We built empires, forged philosophies, and charted the entire globe, all without ever truly seeing it. We were like artisans meticulously carving a single facet of a magnificent jewel, intimately familiar with our own small work, yet utterly oblivious to the gem's total, breathtaking form. The greatest journey of exploration, it would turn out, was not to a new world, but to a new vantage point from which to finally behold our own. This journey would not just challenge our technology and our bodies, it would fundamentally challenge the architecture of the human mind itself, sparking a cognitive revolution for which no one, not the engineers, not the politicians, not even the pilots strapped into their capsules, was prepared. It began not with a theory, but with a feeling, an inexplicable, powerful and transformative sensation that echoed in the hearts of the very first people to break the bonds of Earth. The dawn of the space age was a geopolitical thunderstorm, a high-stakes contest of ideologies played out on the ultimate frontier. The first voyages beyond our atmosphere were not conceived as pilgrimages for philosophers or poets. They were brutal, visceral demonstrations of national power. The men selected for these missions were not chosen for their capacity for introspection. They were the epitome of composure under pressure, steely-eyed test pilots, military officers, men trained to suppress emotion, to focus on switch-flipping precision and engineering checklists. Their purpose was to conquer a new domain, to plant a flag, to survive the unforgiving vacuum and the hellfire of re-entry. They were warriors ascending into the heavens, their minds meticulously drilled to observe data, monitor systems, and report back with cold, objective facts. Yet, from the very first moments, something entirely unexpected began to filter through the static of their mission reports. Through the crackle of radio transmissions between the lines of technical debriefings came whispers of awe, glimmers of a profound internal shift that had no place in the mission plan. Imagine Yuri Gagarin, encased in the Vostok 1 capsule, a metal sphere barely larger than himself, a cramped and lonely outpost of humanity. On April 12, 1961, he was propelled from the Baikonur Cosmodrome by a controlled explosion of unimaginable force. For 8 agonizing minutes, his world was a chaos of violent shaking, crushing G-forces and the deafening roar of the R-7 Semyorka rocket. He was a passenger on a ballistic missile, a human payload aimed at the sky. His training was his anchor in this storm of sensory overload. But then, as the final stage of the rocket fell away, a new reality bloomed around him. The violent symphony of launch ceased, replaced by a silence so absolute, so pure, it was unlike any quiet he had ever known on Earth. In that moment of weightless suspension, he floated to his small porthole, and he looked. For the first time in the 4.5 billion year history of our world, a human being saw it not as a landscape, not as a ground beneath his feet, but as a planet. He saw the gentle, perfect curve of the horizon, a delicate arc set against the infinite velvet blackness of the cosmos. He saw the continents drift by, not as jagged lines on a map, but as organic, flowing shapes of tan and green. He witnessed the impossible, vibrant blue of the oceans, a hue so deep and alive it seemed to pulse with the very energy of creation. And perhaps most startlingly, he saw the atmosphere, the very air we breathe, as a razor-thin, ethereal ribbon of light, a fragile, luminous halo protecting everything he had ever known from the lethal emptiness of space. This was not the Earth of maps and globes. This was a living, breathing entity, a celestial jewel hanging in the void. His official communications back to Mission Control were clipped, professional. The flight is continuing well. I can see the Earth. The visibility is good. But his later, more personal reflections revealed the depth of the impact. I saw for the first time, he would say, how beautiful our planet is. Mankind, let us preserve and increase this beauty, not destroy it. This was not the triumphant proclamation of a conqueror. It was the humble, heartfelt plea of a witness, a man who had left as a Soviet pilot but returned as something more, the the first citizen of a planetary civilization, whether he knew it or not. Less than a year later, the United States sent its own hero to that same vantage point. John Glenn, a decorated marine aviator, was sealed inside the claustrophobic confines of the Friendship 7 capsule. His mission was fraught with peril, a tense drama of technical malfunctions and life-or-death decisions that captivated a nervous nation watching from below. Yet, even as alarms warned of a potentially faulty heat shield that could incinerate him upon re-entry, Glenn's attention was repeatedly stolen by the spectacle outside his window. He too was mesmerized. He described seeing the sun rise not as a slow dawning, but as a sudden brilliant explosion of colour, a spectacle of solid bands of blues and purples and reds that raced toward him at 17,000 miles per hour. He saw dust storms over Africa, the lights of Perth, Australia, which the citizens had turned on as a greeting, and tiny, sparkling fireflies of ice crystals dancing outside his capsule. Like Gagarin, he saw the planet whole, and it was in Glenn's articulate, accessible descriptions that the seeds of a new consciousness began to take root in the public imagination. He spoke with a disarming clarity about the sheer unreality of it all. To look out at this kind of creation, he mused, and not believe in God is to me impossible. But beyond the spiritual awe, he delivered an observation that was profoundly political and deeply human. As he orbited the Earth every 90 minutes, he crossed continents and oceans in the blink of an eye. He flew over nations that were, on the ground, locked in bitter ideological conflict. From his celestial perch, however, the divisions that defined human existence on the surface, the borders, the walls, the checkpoints, the lines of political demarcation that men were willing to kill and die for, were simply not there. They were invisible, fictional. From 260 kilometers up, there was no east or west, no communism or capitalism. There was only Earth. One, whole, and breathtakingly fragile. He had trained his entire life to serve one nation, yet from orbit he saw a world that belonged to everyone. This was the paradox. The Cold War, a conflict predicated on division, had ironically provided humanity with the ultimate image of unity, and the pattern continued. Cosmonaut German Titov, the second human to orbit the Earth, spoke of the planet as a tender, living creature that needed protection. The Mercury astronauts, one by one, returned to Earth with stories that transcended technical jargon. They spoke of the planet's beauty, its tranquility, its apparent vulnerability. These were hard-edged men, products of a culture that prized stoicism, yet they returned speaking a new language of profound connection and unexpected emotion. They had been sent to dominate space, but instead they had been humbled by a perspective of the Earth. For nearly 2 decades, these experiences remained isolated anecdotes, compelling stories told by a handful of extraordinary individuals. They were seen as personal, subjective epiphanies, the natural result of a unique and dangerous adventure. No one thought to connect them, to analyze them as a coherent, predictable psychological phenomenon. The world saw astronauts, but it failed to see the fundamental change happening within them. The feeling had no name, and without a name, it couldn't be studied, it couldn't be understood. It remained a beautiful mystery locked away in the minds of the chosen few who had seen. That all began to change in the late 1970s, not in a NASA laboratory or a university psychology department, but through the work of a writer and thinker named Frank White. White was not a space scientist. His background was in social science and policy at the Space Studies Institute. He was fascinated by the long-term future of humanity in space, by the prospect of orbital colonies and societies beyond Earth. To understand that future, he reasoned, he needed to understand how living in space had already affected people. He began a methodical, deeply curious project. He started interviewing astronauts. He sat down with dozens of space travelers, from the grizzled veterans of the Apollo era to the newer shuttle astronauts. He wasn't interested in the technical details of their missions, the stuff of press conferences and official reports. He asked them different questions. He asked them what it felt like. He wanted to know how it changed them, what they thought about when they looked out the window, and how the experience reshaped their perception of themselves, of humanity, and of the planet they had left behind. As he conducted these interviews, a powerful, undeniable pattern began to emerge from the stories. It was a common thread running through the experiences of men and women of different nationalities, backgrounds, and personalities. They spoke of an overwhelming sense of wonder, a feeling that often transcended their ability to describe it with conventional language. They described a cognitive shift, a moment where their perception of the world suddenly and irrevocably recalibrated. They told him about looking down at the Earth, this vibrant, colourful sphere teeming with life, and feeling an instantaneous, visceral understanding of its interconnectedness. They saw weather systems swirling across entire continents, ignorant of national boundaries. They saw the thin, fragile wisp of the atmosphere and felt a sudden, profound sense of responsibility for its preservation. They described a feeling of separation from the petty squabbles and conflicts of the world below, which from orbit seemed insignificant, even absurd. Many felt a deep, almost spiritual connection, not to a country or a flag, but to the entire human species and the planetary system that sustained it. White realized he was not just collecting a series of interesting travel stories. He was documenting the birth of a new state of consciousness, a distinct psychological event triggered by a specific experience, seeing the Earth from space. This was a shared phenomenon, a predictable outcome of leaving the planet. It needed a name, a label that could encapsulate its power and its meaning, a term that would elevate it from anecdote to a legitimate subject of inquiry. He considered various phrases, but he settled on one that was both simple and profound. He called it the overview effect. The name was perfect. Overview implied more than just a view. It suggested a new level of comprehension, a mental synthesis. It wasn't just about seeing the Earth from a distance, it was about the understanding that came with that sight. It was the effect of seeing the whole system at once, of grasping the big picture in a way that is impossible from within the system itself. By giving it name, Frank White performed a kind of intellectual alchemy. He transformed a collection of subjective feelings into an objective concept. He provided a framework, a lexicon for astronauts to articulate their experiences and for scientists to begin studying them. The publication of his book, The Overview Effect: Space Exploration and Human Evolution, in 1987 was a landmark moment. It formally articulated the phenomenon, laying out its key characteristics. First, there was the recognition of the planet's stunning beauty and its stark reality as an oasis of life in a barren, black void. This often led to an overwhelming emotional response, a sense of awe that could be both exhilarating and deeply moving. Second, there was the newfound appreciation for the interconnectedness of all life and all systems on Earth. The artificial divisions we create simply vanish from view, replaced by the perception of a single, unified biosphere. You don't see the United States or China, you see a planet. Finally, this perspective often fostered a profound sense of responsibility, a feeling that we are all in this together, crew members on what Apollo astronaut Rusty Schweickart would later call Spaceship Earth. It was a shift from an individual or national identity to a planetary one. White's work proposed that this was not merely a side effect of space travel, but perhaps one of its most important and lasting benefits. While the world was focused on the technological spin-offs, on Tang, Teflon and satellite communications, the most significant discovery might be this psychological one. The overview effect was a message, a piece of cosmic wisdom delivered to us via our own technology. It was as if the universe was holding up a mirror, forcing us to see ourselves and our home in a new light. It suggested that going to space wasn't just about exploring other worlds, it was about discovering our own. It was a tool for evolving human consciousness, for pushing us past our tribal instincts toward a more integrated, global awareness. This was a radical idea. It reframed the entire purpose of the space program, shifting the focus from external exploration to internal transformation. The ultimate frontier, White suggested, was not the moon or Mars, it was the human mind itself. But in these early days it remained a philosophical concept, a powerful and resonant idea built on the qualitative evidence of astronaut testimony. It was compelling, intuitive, and deeply inspiring, but it lacked the rigour of hard science. The questions it raised were immense. Is the overview effect a universal human response, or is it unique to a certain type of person, like a test pilot? What is actually happening in the brain during this cognitive shift? Can we measure the changes in neural activity, in emotional regulation, in cognitive processing? Is it the view itself, or is it the combination of the view, the weightlessness, the isolation, and the awareness of risk that triggers it? Could this profound, life-altering experience be simulated or replicated here on Earth for the benefit of all humanity? The anecdotes had given way to a formal concept. Now the concept needed to be tested. The philosophical inquiry had laid the groundwork for a new scientific quest, to map the inner space of the human brain as it grapples with the ultimate outer space perspective. The story of feeling was about to become a story of neuroscience. What returned from the void was not just the person who left, it was the person, plus a revelation. A single voice, echoing from the silent frontier, could be dismissed. You might call it poetry, the understandable rhapsody of a human confronting the infinite for the first time. But then came another, and another. From the cramped, vibrating capsules of Mercury and Vostok, through the ambitious orbital ballets of Gemini, and into the stunning, world-changing voyages of Apollo, a pattern began to emerge, whispered in mission debriefs, captured on crackling recordings, and etched into the faces of the returning crews. It was a symphony of experience, played in different keys by different astronauts from different nations, yet harmonizing around one central, unshakable theme. They had all seen the same thing, not just with their eyes, but with some deeper, more fundamental faculty of consciousness. The first notes of this chorus were of sheer, unadulterated visual splendor. They spoke of colors that earthbound artists could only dream of, a sapphire blue so intense it seemed to vibrate with life, swirling tapestries of white cloud laid over continents of ochre and emerald. They described the sun not as a familiar star in our sky, but as a celestial blowtorch, a terrifyingly brilliant thermonuclear furnace, its light unfiltered and absolute, casting shadows of impossible sharpness. They recounted the profound, velvety blackness that cradled their tiny vessels, a blackness so complete and so ancient it felt like a presence in itself, pricked by the diamond-sharp, unwavering light of 1 billion distant suns. This was the universal overture, the initial shock of beauty that left even the most stoic test pilots grasping for words. But as the missions grew longer, and the time spent gazing back increased, the descriptions began to shift, moving from the purely aesthetic to something far more philosophical, more intensely personal. They began talking about a feeling, a cognitive shift so powerful it was like a rewiring of the soul. Listen closely to their words, and you hear the same realizations echoed across decades. From lunar orbit, Apollo 8's Bill Anders struggled to convey the sight. He saw not a giant, unconquerable world, but a tiny, fragile bauble of life, hanging alone in the vast, sterile darkness. He called it a grand oasis, a precious, irreplaceable jewel. His words were not just a description, they were a plea, a warning. The Earth, from that distance, looked impossibly vulnerable. This was a recurring vision. Astronaut after astronaut would describe the planet's atmosphere, that thin, shimmering membrane of gas that shields us all. From the ground, it seems like an infinite, boundless sky. From 200 miles up, it is revealed for what it truly is, a delicate, ethereal blue haze, as thin and fragile as the skin on an apple. You realize that this gossamer layer is the only thing separating every living being, every breath you've ever taken, every song ever sung, from the lethal, unforgiving vacuum of space. To see it is to understand, in a visceral, bone-deep way, that the life support system for our entire species is terrifyingly finite. This single, stark realization seemed to act as a catalyst, triggering a cascade of interconnected insights. Another theme began to resonate with startling consistency, the complete and utter absurdity of human conflict. From orbit, you don't see the divisions that define us on the ground. The borders, the walls, the ideological lines we draw in the sand, all of them vanish completely. They are revealed as purely human constructs, invisible scars on a seamless whole. You see weather systems swirling over entire continents, oblivious to nations. You watch day turn to night, a silent, graceful Terminator wave sweeping across the planet, uniting everyone in its path. You see the lights of great cities tracing the coastlines, not as capitals of rival powers, but as glowing ganglia in a single, interconnected human nervous system. Saudi astronaut Sultan bin Salman Al Saud described it perfectly. He spoke of seeing nations that were at war with each other on the ground. From his vantage point, he could see both their countries in a single glance, peacefully coexisting under the same blanket of dawn. The pettiness, the anger, the tribalism that fuels our conflicts, it all seemed like a profound, tragic misunderstanding when viewed from above. A kind of collective madness we indulge in because our perspective is too small. This feeling wasn't reserved for any single nationality. Soviet cosmonauts, American astronauts, European, Asian, Canadian spacefarers, they all came back speaking a new, common language of global citizenship. They left the planet as representatives of a nation and returned as emissaries of the entire human race. It was an unsought, unexpected, and completely transformative baptism. They had gone to space to explore the moon, or to conduct experiments, but the most profound discovery they made was the Earth itself. And with this discovery came an overwhelming sense of connection, not just to the planet, but to every other living thing upon it. Apollo 14's Edgar Mitchell described a feeling of intense ecstasy, a sense of universal belonging that washed over him on his return journey. He felt with absolute certainty that every molecule in his body was connected to every other molecule in the universe. He saw the Earth not as a collection of separate objects and beings, but as a single, living, breathing organism. He wasn't alone. Others spoke of a deep, almost parental love for the planet, a fierce, protective instinct for that blue marble hanging in the black. They described feeling the Earth's presence as if it were a companion, its silent, steady rotation a cosmic heartbeat. For some, the experience was deeply spiritual, bordering on the mystical. For others, it was a purely rational, logical conclusion drawn from the available evidence. But the outcome was the same, a fundamental shift in their worldview, a reordering of priorities that placed planetary health and human unity above all else. The consistency of these accounts was becoming impossible to ignore. This was more than just the right stuff mentality of fighter pilots. It was a profound, shared psychological phenomenon. On the ground, a small handful of thinkers and researchers began to take notice. They saw these scattered anecdotal reports not as isolated incidents, but as data points in a fascinating emerging pattern. Among them was a writer and philosopher named Frank White. In the early 1980s, he began a systematic project interviewing dozens of astronauts from around the world. He wasn't a NASA psychologist or a flight surgeon. He was an outside observer, driven by a powerful curiosity. He wanted to understand the inner journey that accompanied the outer one. As he gathered these stories, he realized he was documenting a new category of human experience, one unique to the space age. These men and women were the first generation of a new kind of human, the orbital perspective human. They had been granted a viewpoint previously reserved for gods and angels, and it had irrevocably changed them. White needed a name for it, a term that could encapsulate this complex cocktail of awe, epiphany, global consciousness, and profound connection. He settled on a simple, elegant phrase: the overview effect. The term was perfect. It captured the essence of the experience, that it was the overview, the act of seeing the whole system from the outside, that triggered the profound cognitive shift. It gave a name to the feeling, and in doing so, it legitimized it. It transformed a collection of personal stories into a subject for serious inquiry. Suddenly, science had a target, but this was a target unlike any other. How do you measure a change of heart? How do you quantify a spiritual awakening or a newfound sense of global identity? The challenge for researchers was immense, almost paradoxical. The very thing that made the overview effect so powerful, its deeply subjective, personal and emotional nature, also made it incredibly difficult to study with the objective empirical tools of science. The first major hurdle was the sample size. Even today, fewer than 1,000 human beings have ever been to space. In the context of a scientific study, this is an astonishingly small number. It's statistically insignificant, a mere whisper in the noise of humanity. You cannot draw broad conclusions about the human species from a group smaller than the student body of a tiny elementary school. And this was no random sample. The subjects were, by definition, extraordinary. Astronauts are not average people. They are meticulously selected for their physical and psychological resilience. They are highly educated, technically proficient, and possess an almost superhuman level of emotional regulation and focus. They are trained to suppress panic and to compartmentalize fear. Their baseline psychology is already at the extreme end of the human spectrum, so was the overview effect a universal human response to seeing the Earth from space? Or was it an experience unique to this very specific elite group of individuals? Perhaps their intensive training and unique mindset made them more susceptible to such a profound cognitive shift. There was simply no way to know without a control group, and sending an average person to space just for a psychological experiment was, and remains, a logistical and financial impossibility. The second challenge was the nature of the data itself. The primary evidence for the overview effect came from self-reported accounts, interviews, mission logs, memoirs, and public speeches. While incredibly powerful and moving, this is qualitative, anecdotal data. It's subjective, filtered through memory, language, and personal bias. Science, however, craves quantitative data. It needs numbers, metrics, and repeatable measurements. Researchers tried to develop methodologies to bridge this gap. Psychologists conducted extensive pre-flight and post-flight evaluations, using standardized questionnaires to track changes in values, attitudes, and personality traits. They looked for measurable shifts in things like altruism, environmental concern, and feelings of connectedness to nature. Some studies showed subtle but noticeable changes. Returning astronauts did seem to score higher on measures of universalism and self-transcendence, but the results were often ambiguous, the changes small, and it was difficult to isolate the cause. Was it truly the view from the window that caused these shifts, or was it something else entirely? The experience of going to space is a whirlwind of confounding variables. You're subjected to extreme physical forces during launch and re-entry. You live in a state of constant low-level stress and high-stakes responsibility. You're isolated from your family and the familiar sensory inputs of earthly life. You're exposed to higher levels of radiation. Your very physiology is altered by the absence of gravity. Any one of these factors could have a profound psychological impact. Pinpointing the overview as the sole cause was like trying to isolate a single instrument in a deafening orchestra. Furthermore, there was the problem of expectation. As the legend of the overview effect grew, new astronauts launched with a pre-existing awareness of the phenomenon. They had read the books, watched the documentaries, and heard the stories from veteran spacefarers. Did this create a self-fulfilling prophecy? Were they primed to have this experience, consciously or subconsciously, shaping their own reactions to match the established narrative? It was a psychological version of the observer effect. The very act of studying the phenomenon could be altering it. These challenges created a deep chasm between the lived experience of the astronauts and the scientific community's ability to explain it. On one side, you had a powerful, consistent, and life-altering human story, a chorus of voices speaking with unshakable conviction about a shared truth. On the other, you had a science struggling to find its footing, equipped with tools that seemed too blunt, too clumsy to dissect something as delicate and profound as a change in perspective. The experience resisted easy categorization. It was a psychological shift, yes, but it felt more fundamental than that. It was an emotional event, certainly, but it was rooted in a deeply logical, almost mathematical realization of scale and fragility. It was a spiritual moment for many, yet it was triggered by a purely physical act of achieving a certain altitude and velocity. The attempts to document it, to place it in a neat scientific box, felt like trying to describe a sunset by analysing the chemical composition of the paint. The description would be accurate, but it would miss the entire point. And so, a deeper, more tantalising question began to form, a question that pushed beyond the boundaries of traditional psychology. What if the overview effect wasn't just a response to a beautiful picture? What if it wasn't just a philosophical insight born of a unique vantage point? What if the experience was so profound because it was being triggered by a fundamental change in the very organ that does the experiencing? We had been studying the minds of the astronauts, relying on what they told us after they came home. But what was actually happening to their brains while they were up there, floating in zero gravity, disconnected from the planetary anchor that had shaped our neural architecture for millions of years? Could the absence of gravity, the radical shift in sensory input, and the constant presence of that impossible view be physically remodeling the human brain in real time? Perhaps the quest to understand this phenomenon required a new kind of exploration, not with rockets and telescopes, but with fMRI machines and EEG sensors. The mystery was shifting from the realm of the soul to the domain of the synapse, leading us to wonder if the human brain itself contains a hidden architecture, a latent potential for connection and perspective that only awakens when we truly leave our world behind. For a generation, these stories were treated as sacred texts, whispered between flight crews and mission controllers. They were profound, life-altering testimonies, yet they remained stubbornly in the realm of the personal, the anecdotal. They were poetry, not data. But a fundamental shift was occurring back on Earth, a quiet revolution in our ability to understand the very organ that was having these experiences. The great, unanswered question no longer had to be one of philosophy alone. For the first time, we had the tools to ask, what is actually happening inside the human brain when it leaves the world behind? Can we map the anatomy of awe? Can we trace the synaptic pathways of a planetary perspective? The age of wonder was giving way to the age of inquiry. This pivot from subjective experience to objective measurement marks the most critical turning point in our understanding of the overview effect. It is the moment we began translating the language of the soul into the language of science. The challenge, of course, was immense, an order of magnitude more complex than any previous neuroscientific endeavour. You cannot simply place a functioning MRI machine into the cramped confines of the International Space Station and ask an astronaut to lie perfectly still while hurtling through the void at 17,000 miles per hour. The study of the orbital brain required a more elegant, more patient approach, a forensic investigation of the mind conducted before and after its journey to the stars. The new cartographers of consciousness came armed with technologies that would have seemed like magic to the Apollo generation. Their primary instrument is functional magnetic resonance imaging, or fMRI. This is not a static photograph of the brain structure, but something far more dynamic, a film of the brain in the very act of thinking. It works by tracking the flow of oxygenated blood, the fuel that powers our neurons. When a region of the brain becomes more active, whether it's processing a visual, recalling a memory, or contemplating an abstract idea, it calls for more oxygen. The fMRI detects this subtle rush, this hemoglobin river, and translates it into a vibrant, glowing map of cerebral activity. It allows us to watch, with breathtaking precision, which neural neighbourhoods light up when we feel empathy, when we reflect on ourselves, or when we are struck by a moment of profound insight. To complement this, researchers employ diffusion tensor imaging, or DTI. If fMRI shows us the bustling cities of the brain, DTI reveals the vast, intricate highway system that connects them. It maps the brain's white matter tracts, the bundles of nerve fibers that serve as the communication infrastructure for trillions of neural signals. By tracing the movement of water molecules along these pathways, DTI can reveal the strength, density, and direction of these connections. It shows us not just what parts of the brain are working, but how they are talking to one another. The central hypothesis was tantalizing. Could the intense experience of spaceflight physically alter this wiring diagram, forging new connections while perhaps pruning others? Could the overview effect be, in essence, a large-scale neurological road-building project? These powerful imaging techniques, performed weeks before launch, and then again in the days and weeks after return, provide the crucial before and after snapshots. They create a diptych of the mind, allowing scientists to meticulously compare the pre-flight brain to the post-flight brain, and search for statistically significant changes. But even this presented a complex puzzle, an astronaut's brain is subjected to a whole host of extreme variables. It's not just the view, it's the intense gravitational forces of launch, the constant background radiation, the physiological stress of microgravity rearranging the body's fluids, and the psychological pressures of living in a confined high-stakes environment. How could we possibly isolate the neurological signature of a cognitive shift from all this other physiological noise? The answer lay in bringing a piece of space back down to Earth. Scientists turned to analog environments, places on our own planet that simulate the isolation, confinement, and extreme conditions of space missions. These are our terrestrial laboratories for the astronautical mind. We send crews to the Concordia Research Station in Antarctica, a place so remote and desolate that it is often called White Mars. For 9 months during the austral winter, the sun never rises. Temperatures plummet below -100 degrees Fahrenheit, and the small team is more cut off from the outside world than the astronauts on the ISS. Here, we can study the effects of profound isolation on brain function, independent of microgravity. We send aquanauts to the Aquarius Reef Base, an underwater habitat 60 feet beneath the surface of the Atlantic Ocean. Living and working in this alien blue world, they are utterly dependent on their life support systems, their every move dictated by the hostile environment outside their viewport. It's a powerful analogue for the constant low-level stress and the altered sensory reality of living in a space station. By studying the brains of these Antarctic explorers and deep-sea dwellers, we can begin to build a control group, a catalogue of neurological changes caused by specific stressors. This allows us, through a process of careful elimination, to narrow our search for the unique changes wrought by the singular experience of seeing the Earth from orbit. It's a painstaking process of teasing apart confounding variables, of finding the signal in the static. And now, after years of meticulous data collection from dozens of astronauts and analog subjects, the first glimmers of that signal are beginning to emerge. The results are preliminary, yet they are electrifying, pointing toward a consistent pattern of change in specific, highly sophisticated neural networks. The evidence suggests that the overview effect is not just a feeling or a new idea, but a fundamental recalibration of the brain's machinery for processing reality, self, and other. The first area of intense focus is a network you use every single moment you're not focused on the outside world. It's called the Default Mode Network, or DMN. Think of the DMN as the brain's screenwriter, its internal narrator. When your mind wanders, when you daydream about the future, reflect on the past, or think about yourself and your place in the world, it is the default mode network that hums with activity. It is the neurological bedrock of our ego, the seat of our self-referential thinking. It's the constant inner monologue of me, my, and I. This network is crucial for our sense of a continuous, stable identity. Yet, in many contemplative traditions and psychological therapies, an overactive DMN is linked to rumination, anxiety, and a rigid sense of self. A quieting of this network, conversely, is associated with states of flow, mindfulness, and feelings of being connected to something larger than oneself. The data from the post-flight astronaut scans revealed something astonishing. Across multiple subjects, there was a marked decrease in the resting state connectivity within the default mode network. It was as if the volume on that internal narrator had been turned down. The parts of the brain responsible for incessant self-reflection and ego maintenance were communicating with each other less intensely. This neurological finding provides a stunning biological correlate for the astronaut's own words. When they speak of a dissolving of the self, of their personal anxieties and earthly concerns seeming petty and insignificant, we may be seeing the echo of that experience in the quieted chatter of their DMN. The overwhelming external reality of the planet hanging in the void appears to usurp the brain's internal self-focused reality, forcing a cognitive shift from me to that. It's the first piece of hard evidence that this experience physically disrupts the brain's egocentric framework. But the brain is not just quieting one network, it appears to be strengthening another. This second key finding centers on a region known as the temporoparietal junction, or TPJ. You can think of the TPJ as your brain's empathy engine, its built-in simulator for understanding the minds of others. Located where the temporal and parietal lobes meet, this crucial hub is responsible for what psychologists call theory of mind, the ability to attribute mental states, beliefs, and perspectives to other people. When you put yourself in someone else's shoes, when you imagine how a friend is feeling or try to see an argument from a different point of view, it is your TPJ that is working overtime. It is the neurological hardware for compassion and perspective taking. In the post-flight scans, researchers observed evidence of increased neuroplasticity and functional connectivity associated with the TPJ. It's as though the brain, having been subjected to the most profound perspective shift imaginable, seeing entire nations and historical conflicts reduced to silent, borderless patterns on a sphere, is physically remodeling the very circuits it uses for taking on new perspectives. The external act of seeing the world from a different vantage point seems to be exercising and strengthening the internal capacity to do the same on a conceptual and emotional level. When an astronaut reports feeling an overwhelming sense of connection to all of humanity, a sudden understanding of our shared fate, this may not be mere sentiment. It could be the direct cognitive output of a newly fortified TPJ, a brain that has been fundamentally rewired to more easily transcend its own native point of view. The DMN quiets down, the TPJ ramps up. One network, responsible for the self, becomes less dominant. Another, responsible for understanding the other, becomes more robust. This inverse relationship is the neurological dance at the heart of the overview effect. It is a trade-off, a reallocation of cognitive resources away from the ego and toward a more expansive, empathetic, and interconnected awareness. It's a shift from a self as center model of the universe to a self as participant model. This isn't philosophy. This is the emerging data written in the language of blood flow and white matter tracts. And the story deepens when we consider the role of the brain's ancient emotional centers, particularly the limbic system. The view of Earth from space is not a neutral piece of data like a spreadsheet or a line of code. It is an intensely emotional stimulus. Astronauts describe it with words like breathtaking, divine, blissful. This is the language of awe, a complex emotion that involves a sense of vastness and a need to update one's mental schemas to accommodate the experience. Neuroscientists hypothesize that this powerful awe-inducing stimulus could be acting as a kind of great reset for the emotional brain. It might serve to down-regulate the amygdala, the brain's primary fear and threat detection center, which in our modern world can be chronically overactivated by stress. By providing the brain with a stimulus of unparalleled beauty and significance, the view may offer a corrective experience, a visceral reminder of a context larger than our immediate fears and anxieties. This could explain the persistent reports of increased peacefulness, patience, and a diminished sense of existential dread among returning astronauts. The celestial vista isn't just a pretty picture, it is a therapeutic image of immense power, one that may be capable of recalibrating our deepest emotional and survival circuits. The feeling of safety and belonging that the astronauts describe when looking at our home planet might be the subjective experience of a calmed amygdala and a re-regulated limbic system. So, we begin to see a comprehensive, multi-layered neurological narrative taking shape. It begins with a cascade of novel sensory inputs, the visual shock of the blue marble, the vestibular confusion of microgravity, the altered soundscape of the space station. This massive influx of new information overwhelms the brain's existing models of the world, triggering a state of profound cognitive dissonance. The old frameworks of up and down, near and far, self and other, simply no longer apply. To resolve this dissonance, the brain must adapt. It must physically change. This adaptation appears to manifest as a large-scale reorganization of key neural networks. The self-referential default mode network is dialed down, loosening the grip of the ego. The perspective-taking machinery of the temporoparietal junction is enhanced, boosting the capacity for empathy. And the emotional centers are bathed in an overwhelming signal of awe, potentially recalibrating our baseline for fear and well-being. The result of this complex, intertwined process of neurological rewiring is the subjective state we call the overview effect. It is not one thing, but an emergent property of the brain in radical flux, a cognitive metamorphosis forged in the crucible of space. For the first time, we are holding the faint outlines of a map that leads from the poetic to the physiological, from a feeling to a function. This is no longer a mystery confined to the human heart. It is a scientific frontier opening up within the human brain. The evidence is mounting that going to space doesn't just change your point of view. It changes the very organ that has a point of view. But these are just the first steps, the initial dispatches from an undiscovered country. The critical question that now confronts us is no longer whether this change is real, but how deep it goes, how long it lasts, and most importantly, what it means for the future of our species. If this profound shift in consciousness is indeed a learnable skill, a state the brain can be trained to achieve, could we ever hope to replicate it here on Earth? Could we induce the wisdom of the overview without ever leaving the ground? And so the evidence became undeniable, a set of neurological breadcrumbs leading to an astonishing conclusion. The human brain, that ancient and intricate engine of consciousness forged over millions of years by the unyielding pressures of Earth, is not immutable. It is plastic. It is impressionable. When we leave our world, something inside our own skulls is fundamentally, measurably, and perhaps permanently rewritten. This revelation, a seismic shift in our understanding of the human condition, should have been a moment of pure triumph. Instead, it opened a Pandora's box of complexity and shadow, for the alchemy of space is not a simple, benevolent force. It is a crucible, and within its fires the mind is both elevated and assaulted, clarified and confused. We had found the signal, but now we were deafened by the noise. The grand, beautiful symphony of the overview effect, that feeling of profound connection and terrestrial unity, was not the only sound being produced. Alongside it was a discordant, troubling static, a fog of cognition that astronauts had whispered about for decades. They called it, with a frankness born of experience, the space stupids. It's a feeling of mental molasses, a frustrating slowness where thoughts that once moved like lightning now crawl. An astronaut, a person selected from tens of thousands for their preternatural calm and razor-sharp intellect, might float before a control panel they have trained on for 1,000 hours, only to find themselves staring blankly, a critical checklist item momentarily erased from memory. They might lose their train of thought mid-sentence, or find simple multi-step procedures becoming bewilderingly complex. For a long time, this was dismissed as mere fatigue, the inevitable consequence of a demanding job in an exhausting environment. But the brain scans, coupled with cognitive testing, told a different, more troubling story. The brain wasn't just tired, it was physically reconfiguring itself in response to a biological crisis. When you leave Earth, you leave behind this single most constant environmental pressure that has shaped all life: gravity. Your inner ear, the delicate fluid-filled labyrinth that acts as your personal gravitational gyroscope, is suddenly rendered useless. It sends a cascade of nonsensical signals to the brain, screaming that you are falling, tumbling, spinning, all at once and not at all. It's a state of profound sensory anarchy. To cope, the brain begins a frantic process of recalibration. It starts to ignore the chaotic signals from the vestibular system, relying more heavily on vision to determine which way is up. This isn't a conscious choice, it's a deep, primal act of neurological triage. But this rewiring comes at a cost. The neural pathways being suppressed are intricately linked to spatial memory, to navigation, and even to higher-order executive functions. The very act of adapting to weightlessness seemingly taxes the cognitive engine, siphoning processing power away from other critical tasks. At the same time, the body's fluids, no longer pulled down into the legs, shift dramatically upwards. This redistribution increases the pressure inside the skull, subtly squeezing the brain itself and altering the delicate environment in which our neurons fire. We see its effects in the puffy faces of astronauts, and, more alarmingly, in the swelling of their optic nerves, a condition now known as Space-Associated Neuroocular Syndrome, or SANS. We are, in essence, asking a precision instrument designed for one specific operating pressure to perform flawlessly in a completely different one, all while tumbling through a sensory void. The cognitive fog, then, is not a failure of the astronaut. It is the ghost in the machine, the audible strain of a biological system pushed far beyond its evolutionary design parameters. This physiological onslaught presents science with a monumental challenge, a methodological nightmare from which we are only just beginning to awaken. How can we possibly isolate the transcendent psychological experience of the overview effect from this messy, chaotic, and simultaneous biological adaptation? It is like trying to study the subtle emotional impact of a single violin melody while standing in the middle of a collapsing building. The crash of falling debris, the shrieking of twisted metal, the percussive roar of the demolition. This is the physiological noise of spaceflight. The violin is the view from the window. The question that haunts neuroscientists is terrifyingly simple. Are they even separate phenomena? Or could the profound shift in perspective be, in some small way, a side effect of the brain's desperate scramble to make sense of its new, unearthly reality? Could a change in how we perceive our physical place in the universe, a direct result of vestibular and fluid shift adaptations, be a catalyst for a change in how we perceive our philosophical place in the universe? To answer this, we need data. Clean data. And in the unforgiving laboratory of space, clean data is the rarest commodity of all. The gold standard for any medical or psychological study is a large randomized controlled trial, yet in space neuroscience this is a fantasy. The sample size is infinitesimally small. In the entire history of humanity, only a few hundred individuals have left the planet. Each one is a unique data point, a complex blend of genetics, training and psychology, not an easily categorized subject in a sprawling study. There is no control group. We cannot place 1,000 people in a simulation on Earth and expect it to replicate the experience. You can simulate the confinement, the diet, the workload. You can even simulate weightlessness for brief periods in parabolic flights or underwater labs. But you cannot simulate the total, unceasing absence of gravity for months on end. You cannot simulate the genuine life or death risk, and you absolutely cannot simulate the authentic planet-encompassing view from 250,000 miles away. There is no true placebo for going to space. The tools themselves betray us. On Earth, our window into the working brain is the fMRI, the functional magnetic resonance imaging machine. It is a marvel of technology, capable of tracking blood flow in real time to see which parts of the brain light up during a specific thought or emotion. But an fMRI machine is a behemoth. It requires a superconducting magnet cooled by hundreds of litres of liquid helium to a temperature colder than deep space. It is exquisitely sensitive to the slightest vibration, weighs several tons and consumes a colossal amount of power. Placing such a device on the International Space Station is for now an engineering impossibility. So, scientists are left with a frustratingly blunt approach. They scan the brains of astronauts before they launch, and they scan them again as soon as they return to Earth. But this is like arriving at the scene of a car crash hours after the vehicles have been towed away. You can see the lingering damage, the skid marks, the broken glass. But you have missed the event itself. You cannot know the precise sequence of the impact. The moment an astronaut's feet touch the ground, their brain begins the arduous process of readapting to Earth's gravity, overwriting the very changes we so desperately want to study. We are catching a fleeting echo, a neurological ghost, and from that, we must try to reconstruct the entire living event. So we find ourselves trying to untangle a Gordian knot of confounding variables, each one a thread so tightly interwoven with the others that pulling on one only tightens the rest. Consider the sheer force of isolation. An astronaut on a 6-month mission is profoundly separated from their species, living in a space no larger than a family home with a handful of other people. This extreme confinement and social isolation is a known psychological stressor, capable of altering brain chemistry and function all on its own. We see similar effects in Antarctic research stations and nuclear submarines. How much of the observed brain change is a response to this crushing loneliness, to being a conscious mote of dust in an infinite, uncaring void, and how much is a response to the view of the welcoming blue home you can see but never touch? Then there is the ever-present invisible storm of radiation. Outside the protective bubble of Earth's magnetic field, the human body is bombarded by high-energy cosmic rays, relentless streams of particles that zip through the spacecraft's hull, through tissue and through the brain itself. While the dose is carefully monitored, we are still in the infancy of understanding the cumulative, subtle neurological damage this constant, low-level irradiation might cause over the course of a long-duration mission. Is it possible that some of the cognitive fog, or even some of the deeper structural changes we see, are the scars left by this celestial hail? Furthermore, we must grapple with the power of expectation and selection bias. Astronauts are not ordinary people. They are, by definition, extraordinary. They are individuals who have dreamed of going to space their entire lives, who have dedicated decades to arduous training and study to achieve that singular goal. They are predisposed to find the experience meaningful, profound, and transformative. Their journey is the culmination of a life's ambition. How do we separate the neurological impact of the experience itself from the profound psychological fulfillment of a lifelong dream realized? The emotional high of reaching a personal summit is a powerful force, one that could easily create its own signature in the brain's emotional centers. An astronaut is not a neutral observer. They are a pilgrim arriving at a sacred site. Their awe is preconditioned, their reverence baked in. This does not diminish the authenticity of their experience, but for a scientist trying to find a universal, repeatable effect, it is another layer of confounding beautiful noise. And then there is the view itself, the sublime, terrifying, world-altering image of Earth hanging in the blackness. For decades, we have assumed that this visual stimulus is the primary driver of the overview effect. But is it really just about the photons hitting the retina? Could a sufficiently high-resolution virtual reality simulation, one that perfectly mimics the view from the ISS cupola, induce the same cognitive shift? Early experiments suggest the answer is no. While these simulations can inspire awe and a sense of wonder, they consistently fail to produce the deep, lasting, identity-level change reported by astronauts. This hints that the overview effect is not a passive experience, not something you simply see. It is something you feel, something you inhabit. It seems to require the totality of the experience, the visceral bodily knowledge of weightlessness, the sensory confirmation that you are truly, physically off the planet, untethered from the world of your birth. The phenomenon may not be in the seeing, but in the being. The knowledge that there is nothing but 3 inches of aluminum and the terrifying, beautiful vacuum of space between you and your home is a cognitive weight far heavier than gravity. This forces us to confront the most profound and unsettling questions of all, questions that push beyond the boundaries of neuroscience and into the realm of ethics. If spaceflight is not merely a journey, but a process that actively alters the human brain, the very seat of our personality, our identity, our consciousness, what are our responsibilities? We are, whether intentionally or not, conducting an experiment on the human soul. For astronauts, who are rigorously screened, highly trained and fully consenting adults, the risks are understood and accepted. They are pioneers in every sense of the word, exploring not only the outer world but the inner world on our behalf. But what happens when this experience is democratized? What happens when space tourism becomes routine? When individuals without the psychological resilience or extensive training of a career astronaut can buy a ticket to orbit? Are we prepared for the consequences of offering a brain-altering, identity-shaking experience as a commercial product? A trip to space could become the most powerful therapeutic tool ever discovered, a catalyst for global consciousness and empathy on an unprecedented scale. Or it could be profoundly destabilizing for a mind not prepared for it, a psychological schism from which one might never fully recover. Who gets to decide who is ready for such a transformation? What support structures must be in place for those who return, forever changed, to a world that suddenly seems alien and small? We are standing on a precipice, looking at a technology that offers not just a new destination, but a new way of being human. By sending people into space, we are not just exploring the cosmos, we are tinkering with the very engine of consciousness, pulling levers whose functions we're only just beginning to guess at. It is an act of immense hubris and breathtaking courage, for we have discovered that the path to the stars leads not just outwards, but inwards into the unmapped territory of the human mind. The challenge now, the immense and urgent task before us, is to draw a map. To do so, we must find new ways to observe the mind in its native weightless habitat, to filter the signal from the noise. To untangle this cosmic knot, scientists are realizing they may not need to build bigger rockets or more powerful telescopes. They may need to turn their gaze back towards our own world, to find the hidden corners of our planet, the deepest oceans, the most desolate landscapes, that can serve as imperfect but vital mirrors to the void. Because the next great leap in understanding our place in the universe may not come from a voyage to Mars, but from a journey into the most extreme and alien environments available right here on Earth. The raw human testimony we have just heard, the chorus of voices changed forever by a single vantage point, leaves us with a question that echoes in the silence between worlds. It is a question that shifts our journey from the realm of poetry to the frontier of neuroscience. For if the overview effect is not merely a fleeting feeling, but a fundamental transformation of the human spirit, then its origin must be traceable, its architecture mappable. The evidence for this profound shift must be written, not in the logbooks of a spacecraft, but in the intricate living tapestry of the human brain itself. So we turn from the vastness of the cosmos to the equal vastness within. We descend into the 3-pound universe of folded grey matter, the seat of all consciousness, in search of the neurological signature of awe. This is no longer a mission of exploration, but one of introspection on a species-wide scale, armed with the most advanced tools we have ever devised to look at ourselves. Our search begins in the quietest, most private corners of the mind. Deep within the brain's intricate geography lies a sprawling network of interconnected regions known as the default mode network, or DMN. You know this place intimately, even if you do not know its name. It is the brain's idling engine, the workshop of the self. When your mind wanders during a dull meeting, when you lie awake at night replaying a conversation, when you daydream about the future, that is the DMN at work. It is the tireless narrator of your personal story, constantly weaving memories of the past with anxieties and hopes for what is to come. It is the source of your ego, the incessant inner monologue that reminds you who you are, what you have done, and what you must do next. For most of us, on the surface of Earth, this network is perpetually active, a low hum of self-reference that defines our reality. But what happens when that reality is completely upended? Neuroscientists hypothesize that the experience of seeing Earth from space is so overwhelming, so profoundly other, that it effectively starves the default mode network. The ego's noisy throne room is suddenly flooded with a stimulus it has no framework to process. The usual inputs, deadlines, social pressures, personal histories, are rendered utterly insignificant by the silent, swirling blue marble hanging in the void. It's an experience of pure perception, devoid of self-referential chatter. Advanced neuroimaging studies, particularly functional magnetic resonance imaging, or fMRI, are beginning to provide stunning visual proof of this phenomenon. In subjects experiencing profound moments of awe, whether through breathtaking natural vistas or powerful virtual reality simulations, we see a dramatic and unmistakable decrease in DMN activity. The brain regions responsible for self-obsession literally go quiet. Think of it as a neurological reset. The brain, confronted with a signal of such immense scale and beauty, momentarily suspends its primary directive of maintaining the individual self. It is in this silence, this temporary dissolution of the ego, that the core of the overview effect may be born. This pattern of reduced DMN activity is strikingly similar to that observed in other transformative states of consciousness. It mirrors the brain activity of long-term meditators who have trained for years to quiet their inner monologue. And, in a finding that has electrified the field, it bears a remarkable resemblance to the cerebral states induced by psychedelic compounds like psilocybin, which are known to produce powerful feelings of unity, connectedness, and the transcendence of self. It suggests that the astronauts are not simply having a nice thought, they are undergoing a measurable physiological event. The architecture of their self-perception is being temporarily dismantled, allowing for a new, wider consciousness to emerge in its place. The I becomes we. The sense of being a separate, isolated individual gives way to the palpable feeling of being part of a single, interconnected whole. It's a cognitive rebellion against the tyranny of the self, triggered not by a mantra or a chemical, but by a perspective. But if the default mode network is quieting down, what, if anything, is taking its place? The brain, after all, is never truly silent. As one system powers down, others must surge to process the new reality. This leads us to another critical neural circuit, the salience network. Imagine the salience network as the brain's master conductor, or its spotlight operator. Its job is to constantly scan your internal and external environment and decide what is important, what is worthy of your conscious attention. On Earth, this network is tuned to a very specific set of frequencies. It flags a ringing phone, an approaching vehicle, a rival's promotion, a child's cry. It directs our cognitive resources toward immediate and often personal threats and opportunities. It is the mechanism that keeps us focused on the minutiae of survival and social standing. The salience network, in essence, dictates what we care about from moment to moment. Now place that brain in low Earth orbit. Suddenly, the most salient object in the entire field of view, the most important, compelling, and emotionally resonant thing the human nervous system can possibly perceive is the planet itself. The theory is that this singular planetary stimulus effectively hijacks the salience network. It performs a kind of gravitational recalibration on the very mechanics of what the brain deems important. The network, which evolved to prioritize the rustle in the grass or the deadline on a project, is now completely captivated by the sight of continents drifting by, of thunderstorms blooming like silent fireworks over the ocean, of the impossibly thin membrane of the atmosphere separating life from the void. The brain's cartographer of importance is forced to redraw its entire map. This neurological reprioritization is likely supported by a change in the activity of the amygdala, the brain's ancient alarm system and emotional core. On Earth, the amygdala is exquisitely sensitive to social threats, fear, and anxiety. In space, however, many of those terrestrial triggers vanish. The data flooding the senses is not one of threat, but of profound, overwhelming beauty and fragility. Instead of triggering a fear response, this planetary vista may soothe the amygdala or even co-opt its powerful emotional circuitry to generate feelings of connection and empathy on a scale it was never designed for. When an astronaut reports that their earthly problems seemed to shrink, or felt petty, they are not just offering a poetic metaphor. They are likely describing the subjective experience of their salience network and amygdala, fundamentally shifting their priorities. The brain's very definition of what is significant has been altered. The planet has become the new central subject, and the old subject, the solitary, anxious self, has been relegated to the periphery. This is not just a change in thought, it is a change in the very architecture of attention. This grand-scale rewiring of neural networks does not happen in a vacuum. It is driven, flooded and sustained by a cascade of potent neurochemicals, a unique cocktail mixed by the brain in response to this unprecedented experience. While we cannot yet place a probe into an astronaut's brain mid-flight, our understanding of how the brain responds to awe, novelty, and connection on Earth gives us a compelling blueprint. The first and most obvious player is dopamine. Often misunderstood as a simple pleasure chemical, dopamine is more accurately the chemical of motivation, seeking, and salience. It is released in response to novelty and the anticipation of reward. The view of Earth from the cupola is arguably the most novel and rewarding visual stimulus a human being can experience. The constant, gentle drift of the planet, revealing new patterns and new coastlines every minute, would likely trigger a sustained, low-level release of dopamine, creating a state of profound engagement, focus, and wonder. It's the neurological basis of fascination, keeping the astronaut glued to the window, absorbing every detail. Flowing alongside this current of dopamine would be serotonin, the molecule most closely associated with mood, well-being, and a sense of peace. The sheer tranquility of the orbital environment, the silent, graceful motion of the station, and the absence of terrestrial stresses could elevate serotonin levels, contributing to the feelings of calm, contentment, and profound rightness that so many astronauts describe. It is the neurochemical antidote to the chaotic, often stressful nature of life on the ground, creating a mental space where a more profound perspective can take root. But perhaps the most crucial ingredient in this cocktail of transformation is oxytocin. Famously known as the love hormone or bonding chemical, oxytocin is fundamental to social connection, empathy, and trust. It is what allows a mother to bond with her child, what cements the connection between partners, what fosters a sense of belonging within a community. Now imagine what happens when the object of that potential bonding is not another person, but the entire human family, presented as a single unified entity. Seeing the Earth without borders, without the visible scars of conflict, seeing the shared atmosphere and oceans that connect us all, this may be the ultimate trigger for a massive system-wide release of oxytocin. The brain's social circuitry, designed for small tribes, is suddenly scaled up to the planetary level. This could be the direct biological mechanism behind the astronauts' overwhelming feeling of connection to all of humanity, the powerful urge to protect this fragile home. Their brains are, in a very real sense, falling in love with the world. The combination of dopamine-driven fascination, serotonin-induced peace, and oxytocin-fueled connection creates a potent neurochemical state, a state uniquely conducive to insight, compassion, and a radical shift in perspective. The overview effect from this vantage point is the subjective experience of a brain saturated in the very chemicals that make us our best selves. A profound experience, however, even one backed by powerful neurochemistry, can fade. The true significance of the overview effect lies in its permanence. Astronauts don't just feel this way in orbit, they bring this change home with them. It informs the rest of their lives. This points to the final and perhaps most remarkable piece of the neurological puzzle, the principle of neuroplasticity. This is the brain's miraculous ability to physically change its own structure and function in response to experience. The old idea of the adult brain as a fixed static organ has been completely overturned. We now know that the brain is constantly remodeling itself. Every thought you have, every skill you learn, carves and reinforces neural pathways. As the saying in neuroscience goes, neurons that fire together wire together. This is the physical basis of all learning and memory. The sustained, awe-inspiring experience of viewing the Earth is not just a passing thought. It is a powerful, repetitive, and emotionally charged event. Each time an astronaut floats to the window and experiences that surge of wonder, connection, and insight, a specific set of neural pathways is activated. The quiet DMN, the retuned salience network, the circuits flooded with oxytocin and dopamine. Day after day, for months on end, this unique pattern of brain activity is repeated. This sustained activation is the very definition of neuroplastic training. The brain is, quite literally, practicing a new way of seeing the world. This experience acts like a celestial blowtorch, forging powerful new connections between regions of the brain that might not normally communicate so intensely, linking visual cortex with emotional centers and social cognition networks with areas responsible for abstract thought. Think of the brain's existing pathways as well-worn riverbeds, carved by a lifetime of earthbound, egocentric concerns. The overview effect is like a colossal sustained flood. It doesn't just flow through the old riverbeds. Its sheer force carves new channels, new tributaries, creating a permanent change in the landscape of the mind. The new, globally oriented perspective becomes more than just an idea. It becomes a structural reality, a default pathway for thought. It becomes easier and more natural for the brain to think in terms of the collective, to feel empathy for the whole, because the very wiring that supports that perspective has been strengthened and myelinated. Psychological profiling of returned astronauts provides compelling behavioral evidence for this lasting change. Decades after their missions, they consistently score higher on measures of universalism, altruism, and environmental concern. They dedicate their lives to humanitarian causes, to diplomacy, to protecting the planet. This isn't a post-mission publicity strategy. It is the long-term echo of a mind that has been fundamentally and physically rewired. So here, in the intricate dance of neural networks, neurotransmitters, and the living clay of the brain itself, the mystery of the overview effect begins to yield its secrets. It is not an illusion or a flight of fancy. It is a cascade of observable, measurable neurological events. It begins with the silencing of the ego in the default mode network, creating a space for a new perception to be born. That perception is then guided and prioritized by a recalibrated salience network, which locks onto the planet as the new object of ultimate importance. This entire process is fueled by a potent chemical cocktail of awe and connection, bathing the brain in the very molecules of empathy and wonder, and finally, through the relentless power of neuroplasticity, this new state of mind is carved into the very structure of the brain, becoming not just a memory, but a new and enduring part of who the person is. We are witnessing the human brain's astonishing capacity to adapt and transform in response to its environment. We have built a machine to leave the world, only to discover it is also a machine for changing the mind. We have peered into the machinery of consciousness and found the gears of transcendence. We have laid the scientific foundation for what was once the sole territory of poets and mystics. But knowing how this transformation happens is not the end of our journey, it is in fact a startling new beginning. For if the human mind is this malleable, this capable of such a profound and positive recalibration, it begs an even more important question. What do we do with this knowledge? If we have discovered a key that can unlock a more connected, more compassionate, and more planetary perspective, how and where should we now use it? The implications stretch far beyond the confines of a space station, reaching down to the very surface of the world we have just learned to see in a new light. Our long ascent is over. We have journeyed from the hushed confessions of returning heroes, from whispers of a profound and ineffable transformation, to the very architecture of the human mind where that change is forged. What began as poetic anecdote, a collection of deeply personal yet strangely congruent stories from the pioneers of spaceflight, has now found its grounding in the intricate electrochemical reality of our own neurology. We have traced the subtle quieting of the brain's egocentric narrator, that relentless hum of the default mode network, as it momentarily yields to a grander signal. We've witnessed how the temporoparietal junction, our internal gyroscope for social perspective, recalibrates its sense of other to encompass not just a person or a nation, but an entire world teeming with life. The ghost in the machine has been given a name, a location, a measurable signature. The overview effect is no longer a mystic's dream but a neuroscientific reality, a fundamental cognitive shift catalyzed by an unprecedented vantage point. We have moved beyond the why of its emotional power and into the how of its biological mechanism. We now understand that seeing Earth from orbit is not merely a visual experience. It is a full-body, top-down rewiring of the brain's deepest assumptions about self, place, and connection. The silent, weightless fall around our planet appears to trigger a cascade, dampening the neural circuits dedicated to self-obsession and tribal division, while amplifying those responsible for empathy, awe, and the recognition of a single, unified system. The feeling of oneness, described with such frustrating beauty by astronauts, is the subjective echo of a brain physically remapping its relationship to the whole. We have, in essence, completed the first definitive neural cartography of this extraordinary state of consciousness. It is a map that validates the testimony of every astronaut who struggled to find the words, confirming that their experience was not hyperbole, but a truthful report from a newly configured mind. This journey from qualitative feeling to quantitative fact cements the overview effect as one of the most significant psychological discoveries of the space age. It proves that our environment, taken to its most extreme scale, can sculpt the very core of our being. We are not static observers of the universe, we are participants, our consciousness a sensitive instrument tuned and retuned by the cosmic vistas we dare to witness. And with this new, hard-won understanding comes a cascade of profound and urgent questions. For if we now hold the map, we must decide where it leads. The implications of this discovery ripple outward, far beyond the confines of the laboratory, touching the very future of our species, both on this world and among the stars. That future begins on a long, desolate road paved with red dust. The human journey to Mars represents the greatest migration in our history, an endeavour of unprecedented technological and psychological resilience. It is a mission that will stretch the bonds of the human mind to their breaking point. For the crews making that multi-year voyage, Earth will not be a majestic swirling marble hanging in the window. It will shrink, day by agonising day, from a comforting blue sphere to a bright star, and then to just one insignificant point of light among countless others. It will become an abstraction, a memory. And here, our newfound understanding of the overview effect transforms from a fascinating discovery into a critical mission parameter. We have seen how the persistent visceral presence of Earth forges new neural pathways of connection and perspective. So what happens to the human brain when its cosmic anchor is cut loose? Imagine the psychological state of an astronaut, 9 months into the void, when the planet that has defined every moment of human evolution is no longer visible as a world. The very stimulus that quiets the ego and fosters a sense of unity is gone. Will the default mode network, deprived of its planet-sized pacifier, roar back to life with amplified anxieties and obsessions? Could the isolation of deep space without the terrestrial backdrop lead to a dangerous fracturing of crew cohesion, a turning inward that fosters suspicion and conflict? The psychological stakes are immense. A crew suffering from a kind of overview withdrawal would be a crew at risk, their cognitive and emotional resilience compromised just as they face the most demanding phase of their mission. Space agencies are now grappling with this nascent field of neurostewardship. They are no longer just training astronauts to be pilots and scientists. They are preparing them to be guardians of their own consciousness. This has given rise to a fascinating and ethically complex field of research: the development of simulated overview experiences. Advanced virtual reality systems, fed by ultra-high-resolution data from orbital satellites, are being designed to give astronauts on a Mars-bound craft the ability to return to low Earth orbit on demand. They can float in a virtual cupola, watching simulated continents glide by, listening to the hum of a virtual space station. The goal is to periodically trigger those same neural pathways, to provide a dose of the awe and interconnectedness that the real view provides, staving off the psychological decay of profound isolation. But this raises a philosophical quandary. Can a manufactured epiphany ever be as potent as the real thing? Is a digitally induced sense of wonder a genuine therapeutic tool, or is it a pale imitation, a technological crutch that might fail when needed most? And what does it say about us that we must now engineer the very experience that reminds us of our humanity? The success of our first steps onto another world may depend on how well we can carry the neurological echo of our own. It is a fragile, precious cargo, and we are only now learning how to pack for the journey. While humanity's best and brightest prepare for Mars, a new chapter in the human-space relationship is unfolding much closer to home. The airlock, once the exclusive domain of national space programs, is being pried open. We are at the dawn of the age of commercial spaceflight, the democratization of the heavens. For the first time, the journey to the edge of space is becoming a product, a service, an experience available not just to the rigorously selected few, but to anyone with the considerable price of a ticket. Thousands, and soon perhaps millions of human brains will be exposed to the very same catalyst that so profoundly altered the first astronauts. This is no longer a controlled experiment. It is a global one, and its outcome is entirely unknown. What happens when this powerful neurological key is placed into the hands of a civilian population? The potential is as staggering as it is unpredictable. Imagine a world where a significant number of industry leaders, politicians, artists, and influencers have personally witnessed the fragility of the biosphere from above. Could a CEO, having seen the paper-thin membrane of our atmosphere, return to Earth and fundamentally shift their company's environmental policies? Could a nationalist leader, having seen the seamless continuity of continents without borders, soften their rhetoric and embrace a more globalist perspective? The science suggests this is not just a hopeful fantasy. A brain rewired for a greater sense of the collective, with a dampened ego and an enhanced capacity for awe, is a brain primed for long-term systemic thinking. This infusion of the orbital perspective into our global leadership could, in theory, act as a powerful catalyst for positive change, a cognitive antidote to the short-sightedness and tribalism that plague our civilization, It could be the shared experience that finally unites a fractured world. But there is a competing, more cynical possibility. The original astronauts were on missions of science and exploration. They were prepared minds, embedded in a culture of purpose and reflection. Will the overview effect be diluted when it becomes another adventure on a billionaire's bucket list? Can a 10-minute suborbital flight sandwiched between champagne and a luxury debriefing truly impart the same lasting transformation as days or weeks spent living and working in orbit? Perhaps the experience will be treated as little more than the ultimate rollercoaster ride, a fleeting thrill whose profound meaning is lost in the spectacle. The neurological shift may occur, but without the mental and emotional framework to integrate it, the change could be transient, fading like the memory of a vivid dream. The grand social experiment of space tourism is therefore a race between genuine transformation and trivialization. Will we use this extraordinary tool to elevate global consciousness, or will we reduce one of the most profound experiences available to humanity into the ultimate status symbol? The answer will shape the 21st century, determining whether space becomes our mirror or just another playground. Ultimately, the most powerful implication of everything we have discovered is not about where we are going, but about how we see where we already are. The great irony of the space age is that its most enduring legacy may be terrestrial. The journey outward, we now see with neuroscientific certainty, is a journey inward. But even more than that, it is a journey backward, to the home we thought we knew. The overview effect, in its purest form, is not about the beautiful infinity of the cosmos. It is, and always has been, about falling irrevocably in love with the Earth. It is the shocking, visceral, system-wide realization that everything we have ever cared about, every war ever fought, every love poem ever written, every moment of human triumph and despair is contained on that fragile living sphere below. It is a perspective machine that annihilates abstraction. Down there, the environment is no longer a political buzzword. It is the visible, breathing system that is keeping you alive. Humanity is no longer a faceless mass. It is the invisible, interconnected consciousness that painted the lights on the continents below. This is where the science becomes deeply personal, where the firing of neurons in the temporoparietal junction has the potential to reshape geopolitics. The cognitive shift from an egocentric to a planet-centric model of the self is the very definition of stewardship. It is the neurological foundation for a sustainable civilization. A brain that has experienced this shift does not see a world of competing nation-states. It sees a single, complex organism. It doesn't see isolated environmental crises, it sees a systemic fever. The borders, so stark and important on our maps, are revealed from orbit for what they truly are: imaginary lines drawn by a species that has temporarily forgotten it is a single family. For decades, we have tried to solve our greatest challenges: climate change, resource scarcity, global conflict, using the same modes of thought that created them. We have appealed to logic, to fear, to economic incentive, but the overview effect suggests we have been trying to solve the problem at the wrong level. Perhaps the solution is not a new policy, but a new perspective. Perhaps what we need is not more data, but more awe. To save our world, it seems, we first needed to leave it, if only to finally see it for what it is. Spaceflight has become a cosmic mirror, and for the first time we are able to see our own reflection, whole and unbroken. We stand at a remarkable precipice in our journey as a species. For millennia, our consciousness was tethered to the surface of this world, our perspectives shaped by the horizon line. Our brains evolved to navigate the savannah, to form tribes, to distinguish friend from foe with brutal efficiency. Those same neural circuits, so vital for our survival, are now the source of our greatest existential threats. But we have, through our own ingenuity, created a technology that offers a way out. We have built a cognitive scaffold that allows us to climb out of our own evolutionary cradle and look back at ourselves. This is more than a psychological phenomenon. It feels like the early tremors of a new phase of human evolution. We are not just exploring space, we are actively seeking out an experience that upgrades our own mental software, allowing us to run programs of empathy and global cooperation that were previously incompatible with our basic hardware. Perhaps this was always the path. Perhaps a species cannot become a true planetary steward until it has seen its planet from the outside. Perhaps the final test of any intelligent civilization is whether it can invent the technology to leave its home, not as an escape, but as a rite of passage, a way to gain the wisdom necessary to manage it properly. We are the universe's way of becoming aware of itself, and in the silent reflection of an astronaut's helmet, we see the profound truth of that statement. We see a consciousness that has been forged in the crucible of this planet, now looking back with new eyes, rewired by the journey and ready to embrace its role. The ascent is over, but the real work, the work of bringing that orbital perspective down to Earth for everyone, has only just begun. The blue marble keeps turning, waiting patiently for the rest of us to catch up.